Hello, my name is Kevin Hickey. I'm the CEO of Prevalent. And with schools and offices shut down and most of us working from home and spending time with our families, the Prevalent team wanted to provide a little fun break with a special online presentation with Scott Flansburg, the human calculator. Scott's been a good friend for over 30 years. He's appeared on shows like The Oprah Winfrey Show, Ellen, The Today Show. He is the Guinness World Record holder for the fastest human calculator, and he's also the founder of the Counting Bee. Whether you're home alone with your spouse, young children, or young adults, I think you'll find there's something for everyone. But before we start, I want to assure everybody we've taken every healthcare precaution necessary to put this webinar on. The camera is being operated remotely by phone. We're all practicing social distancing. This office is closed. There's 3 people in here, and I promise you we're taking every precaution. Wanted to kick back, have a little fun, and I'm going to turn it over to Scott now, and hopefully you'll all find this enjoyable. We are going to record this session, so it'll be on our website in the future if you want to go back for any references for some fun tips that you've learned from Scott today. Have a great day.
Okay. Well, thank you, Kevin, and I want to thank the Prevalent team for having me today. I'm very excited about this opportunity because we're all in a unique situation, and so I just want to make it as fun as I can here today. We're not going to cover a lot of stuff. We're just going to cover stuff that'll help everybody. So to get started, I need Kevin to help me warm up my brain. And so what we're going to do is start with number calculations. So I'm going to try to do them in my head, and Kev's going to do them on his calculator. So here we go. This is called an app called Digits. And so, Kev, you get started. We're going to start out. I got to warm up my brain. I'm not an athlete. I'm a mathlete, so I have to stretch out a little bit. So let's do some addition of 2-digit numbers, a bunch of them, and I'll say plus between each 2-digit number. It tells you I'm ready for the next one.
Okay.
I'm ready.
7, 8, 9.
Oh, no, sorry, clear it out. Just a bunch of 2-digit numbers, like
okay.
56, 73, stuff like that. Sorry, we'll get into the bigger stuff later.
All right. 49.
49 plus
73.
Plus
23
plus
89
plus
74
and one more.
86.
394. Did you get 394? All right. Okay. So I'm going to show you how to do that in a couple minutes. All right. I figured out how to do this when I was in 3rd grade by accident. But let's keep going. Kev, let's do some multiplication. Just give me like two-digit numbers and I'll multiply them in my head.
Sure. 89
times
93.
That's 8277. Is that right? Did I get it? 82. Yeah. All right. I'm still warming up. Let's go for division. Give me like a 3-digit divided by a 1-digit.
789 divided by 3.
263. Try another one. That was pretty easy. Pick tough numbers.
Okay. 927 divided by 7.
That's 132.4285714285, yada, yada, yada. It just keeps going forever. Okay, so now I'm warmed up. So what I want to demonstrate for you next is something I discovered I could do when I was in about 8th grade. Kev, just for fun, clear your calculator, punch in 12 plus 12 and hit the calculator and hit equals. And it'll say 24, but hit equals again and watch what happens. It adds 12 more. And if you hit equals again, it should add 12 more. And now you just keep hitting equals. It'll count by that number. And my buddy Andy did that in front of math class one day. And he said, hey, Scott, what's 28 plus 28? I said 56. And he accidentally hit equals again. And it added 28 more. And he goes, hey, what's 28 more? And I said, well, that's 84. And he goes, what's another 28 more? And it was like something woke up in my brain. And now I've had this Guinness World Record for over 20 years as fastest human calculator. And so here's how it works is the Guinness people gave me 15 seconds to race the fastest accountant in the world using a 10-key calculator. The judge chose 38. So the guy in the calculator had to do 38 plus 38 plus 38 plus 38 plus 38 as fast as he could for 15 seconds, racing me, counting by 38 out loud. At the end of the 15 seconds, he had 28 answers and I had 36. So I actually beat the machine by 8. And so Kev, clear this out. And now pick a tough 2-digit number you want me to count by. Don't tell me what it is yet. Just punch it in and then hit the plus sign and then hit the same 2-digit number again and hit equals. And I'm just going to start counting by that number. And you just hit equals and keep up with me as I say the next answer. I'm ready when you are.
87.
174, 261, 348, 435, 522, 609, 696, 783, 870, 957, 1044, 1131, 1218, 1305, 1392, 1479, 1566, 1653, 1741, 8271, 94, 2001, yada yada. 2001, that was a good year. Okay, so you can see I can just count by a number as fast as I can talk. My mouth actually slows me down. My brain is going so fast when that happens. The numbers are just flying through there. But when I filmed this for Guinness, I did this and I set the record, 36 answers in 15 seconds. That's been there for about 20 years now. We went to a commercial break and the guy said, "Hey, Scott, you're in the book, but we think you're cheating." And I was like, "How do you cheat counting by 38? And he goes, "Well, we don't think you're actually counting. We think you've memorized all these answers." And I said, "That would be even more amazing to memorize all those numbers." And I said, "So instead, what about, instead of starting at 0, we start at a random number." So Kev, punch in a random 2 or 3 digit number. And I can see it. It's okay. It doesn't matter. 249. Now hit plus. So our starting number is 249. And now you hit plus. Now pick a 2-digit number you want me to count by starting at 249. And just say it out loud.
49.
That's too easy. Clear it out. Let's start over because you had a 49 in the first one. I could, anybody could do that, right?
49, we'll still start there.
249 plus
78.
So I've never done this pattern before. Here we go. 327, 405, 483, 561, 639, 717, 795, 873, 951, 1029, 1107, like that. I can still go the same speed. And so I am tuned into numbers. And then I hosted the Olympics for mental math. It's called Memoriad for mental math world records in Las Vegas in November 2016. And I got challenged for my record, and the girl that challenged me wanted to do a 3-digit number. So that hasn't aired yet, but we're going to do it right now just for fun. So Kev, be gentle, don't go crazy on me, but pick like a 3-digit number, and then don't tell me what it is yet. Punch it in, and then hit plus, and then the same 3-digit number, and hit equals. And I'm going to start counting by that 3-digit number.
Sure. The number is 249.
498, 747, 996, 1245, 1494, 1743, 1992, 224, 12490, 273, 9298, 3247, like that. Just as fast. I can just fly. As soon as I ask my brain that question, the numbers just start flying. And so I'm really tuned into numbers. And so the rest of the show I want to spend showing you how to see numbers and make it easier for you in everyday life. So Kev, thank you very much. Great job. But now I want to get started with something real simple. And I'm going to start back when I was in 3rd grade. Our teacher wrote these 4, I got to put this on here. Just give me 1 second. Screen mirror, yes. And so what I want to do is show you what happened to me is I was in 3rd grade. Our teacher wrote this problem on the board. We had already learned how to add up single digits, and we were learning carrying with 2-digit numbers. And she showed everybody how you have to go start at the 7 and the 2 is 9, 1 more is 10, 3 more is 13, write down the 3, carry the 1, 1, 2, 3, 4, 5, and you add it up and there's your answer. And the only problem was I wasn't paying attention that day. I sat next to my best friend in class and we'd always talk about baseball. We were on the same team, so we really didn't focus much on this. And my teacher caught me not paying attention. So she picked me to come up to the board to do this problem. And I always use these 4 numbers to start my show because they're seared in my brain because of the anxiety that I felt as I was walking up to the board realizing that I was busted and I didn't know what to do. I didn't know where to start. I didn't know what the carry was. And so I walked up to the board and out of fear or survival, I'm not sure why, my brain was like, okay, I learned how to read left to right. So I must have to do my math left to right. So I started over here in the tens column and then worked that way. So here's how I did it and see if it makes sense to you. This is a 10, 10, 10, 10. All I did was keep a running total going down the columns backwards. So watch this. 10 plus 10 is 20, plus 10 more is 30, 10 more is 40. Now we can stop right there and you just learned estimation. So this helps with estimation, but let's keep going. We're at 40. 40 plus 7 is 47. Plus 2 is 49. Plus 1 is 50. Plus 3 is 53. And that's the answer, 53. And I wrote that down without a carry. And my teacher said, well, you're right, Scott, but where's your carry? And I said, I don't know what you're talking about. What's a carry? And she said, well, let's try another one. So you guys try this one out. This was the next one she gave me. I always use this one too. All right, and just try it on your own first, then we'll do it together. I'll give you a couple seconds here. Always starting on the left. You learn estimation, number sense, place value. It's amazing. Okay, I'm sure some of you already got the answer. Let's try it. So this goes 20 plus 20, which is 40. 20 more is 60. 10 more is 70. So estimation, 70 something or higher. 70 plus 6 is 76, plus 3 is 79, plus 1 is 80, plus 8 is 88. So I promise you, you might have never seen that before in your life, but this is as simple as it gets. Let's try one together. Everybody do this on your own. Race the people you're watching the show with right now. Just shout out the answer when you get it. Kev, I don't hear you yet. No, not even close. That was totally, I don't even think you were looking at the numbers. So here's how it works. So let's try it together. We got 30, 50, 60, 70, 77, 79, 80, 85. The answer is 85. I hope you got that right. And now, I just wanted to break the ice with this simple thing because I discovered this by accident when I was in 3rd grade. But what happened was it made me question everything I learned the rest of my life. In 4th grade, I had a tough time with my math teacher. He was my way or the highway. And 5th grade, I got very lucky. I had a teacher named Mr. Potter. And Mr. Potter goes, Scott, I've already heard about you. He goes, if you figure something out in my class, you bring it to me. And if I can prove that it works algebraically, that it's not just a trick, then I'll let you teach it to the rest of the class. So I'm just going to give you one example. I cover everything from addition to algebra in all my programs. Today, we're going to just do a couple things, but it's funny, when you get into memorization, everybody memorizes up to 10 times 10. Some people all the way up to 12 times 12, but really, that's about it. If you ask somebody 13 times 14, nobody has the answer. So we all quit at 10, but to me, I couldn't believe we were stopping at 10 because 11 seemed like this amazing number. Watch this. When you multiply numbers times 11, there's a simple pattern. You know, we could do it the way you normally do it. You got to do 4 times 1 is 4, 2 times 1 is 2, put the 0, then you got to, do it this way, and, you end up with 240 and 24 and all that. You got to add them all together. It's a lot of work. But watch how easy this is now. Anytime you have to multiply a number times 11, just go like this. Drop the back number here, drop the front number here, and now just add these two together. 2 plus 4 is 6, and drop that in the middle, and there's your answer. All right, let's try another one. 35 times 11. First step is you drop the numbers down from the top onto the ends. And now 3 plus 5 is 8, so 385, all right? You should be able to do this pretty easily in your head. So let's just practice one. Let's do 33 times 11. Everybody try it in your head, then I'll write it down so you can visualize it. A lot of people are very visual when it comes to math. So 33 times 11, you're going to have a 3 here, a 3 here, and 6 goes in the middle. This works all the time, 3-digit numbers, 4-digit numbers. There's a carrying process in here if you want to try it. But if your kids love this, just have them try bigger and bigger numbers, and they'll discover all these patterns and figure out how it works instead of just making them memorize how it works. What I try to teach people to do is how to discover numbers, not memorize numbers. So this is my biggest concern is it seems like it's become socially accepted to be bad at math. And we all carry one of these in our pocket now. We all have a calculator. Take a look at the calculator for a second. You take it for granted. How many numbers are on a calculator? Some of you probably said 9, 10. I've heard 11, 12. I've heard 6. It's crazy, all the different answers when I visit schools and stuff. But it's really funny is look at this calculator. This is the most powerful machine. Now we have them on our phones and in our pockets and everything. But this at one time was a big thing. It took a lot of space to crunch numbers. And now it's down to this. Today, this show, I'm speaking to you in English. When you speak English, you have to use the alphabet, A, B, C, D, and make words and sentences and all that stuff. Well, when I'm the human calculator and I'm speaking the language of numbers, I use the alphabet of numbers, which are these 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's no 10 on a calculator, yet we've all been brought up to think like this. We have 10 fingers. We've all learned to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's cool if you need to count your fingers. But if you want to think like a calculator, you have to count 0. Because when you turn on a calculator, it always starts at 0. So you have to count 0. So really, numbers work like this. We have 10 fingers, and there's 10 digits, and it goes like this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's really 0 through 9. And I can't explain why the world is wired 1 through 10, but all I can tell you is when you start thinking about numbers 0 through 9, everything changes. It makes numbers so much easier. All these patterns start jumping out of the bigger numbers. You can see them. And so what I want to do is just introduce you to this language of numbers. Here's the 10 digits, and there's all kinds of different stories about how these numbers got their shapes. When I was a kid, I asked my 3rd grade teacher, how did the numbers get their shapes? Who picked the shapes? And she said, I don't know. We asked other teachers, they didn't know. And so I sort of made it my mission to find out why numbers look like they do. And if you go online now, you can find these beautiful graphs that'll show you how they evolve through the years. But for helping kids connect with numbers, one of the cool ways I saw that numbers maybe came about, which isn't probably true, but it's a great way to help the kids with numbers, is that these shapes were made to be able to communicate to you the value of each shape by one simple thing. Here's how 0 started. 0 is a circle. The secret is to count the corners of each shape. So I'm going to show you how they originally looked to make this happen. But now you can see why 0 is a circle, because they wanted to communicate that this had a value of 0, so there are 0 corners. The next number 1 started out like this. It had a little thing right there. That's 1 angle. So everybody knew when they looked at that shape, that value had a shape had a value of 1. The number 2 started out like our letter Z, because this shape has 2 corners, 2 angles. So everybody knew that was 2. The number 3 started out like this. It gives you 1, 2, 3 angles. There's your 3. And the number 4 looked a little different. It looked like that. And this gives you 1, there's 1, 2, 3, and then 4, the outside angle. And then the number 5, it looked almost the same. It just has a little tail on it like that. That gives you 1, 2, 3, 4, 5 angles. The number 6 started out like this. They just boxed it up. That gives you 1, 2, 3, 4, 5, 6 corners, 6 angles, all right? 7, we're lazy, we draw it like that, but somebody really smart came up with this a long time ago, and now you have 1, 2, 3, 4, 5, 6, 7 angles. And you'd think 8 would be tough, but 8 is actually very easy. They just use this hourglass symbol. So you've got 1, 2, 3, 4, 5, 6, 7, 8 with the outside angles. And then 9, they actually called this one the ugly duckling, but it got the job done. It looked like that. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So there you go. It's really 0 through 9. And now you know why numbers look like they do. And you know 10 is not a digit. 10 is a number that uses a 1 and a 0. So it's really 0 through 9. And when you turn on a calculator, it always starts at 0. If it started at any other number, you wouldn't get the right answer. So 0 is the power number when it comes to a calculator. But now if I want to show you how to make numbers add up to 9, because the secret to numbers is everything goes back to 9, which I'll share with you in a minute. But a lot of you have just memorized your math facts. Just say the answer out loud as fast as you can. What's 7 plus 7? I'm sure everybody yelled 14 within half a second. How are you getting that answer so quickly? Were you counting your fingers? Were you calculating something? Or did you just memorize that? That's what we do in our schools. Our kids, the parents and the teachers just want to make sure the kids have the answers. The easiest way to get that is just have the kids memorize their math facts at the beginning of school, which really doesn't serve a good purpose. It's a bad way to get started, I think. So today, I'm going to introduce you to what I call Chapter 0. I believe it's the missing chapter in arithmetic. And if students around the world would learn this chapter first, it would make the job easier for our teachers and our parents and for everybody to make sense out of arithmetic and move on to higher maths and get into science, technology, engineering, arts, and maths, okay? So before we get into adding or any secrets, I got to show you a simple pattern to help you realize how simple 9 is. If you're not good at adding, just do this. Start writing your digits, 0, 1, 2, 3, 4, and now keep going underneath, 5, 6, 7, 8, 9. And look what happened. You can see that 0 plus 9 is 9, 1 plus 8, 9, 2 plus 7, 9, 3 plus 6, 9, and 4 plus 5, 9. Those are all the combinations to make 9. And so after you write this down and you get your students to go through this, what I do as a quiz is I'll just say one of the digits and make them say the other number that makes both of them add up to 9. So if I say 4, they have to say 5. If I say 7, they have to say 2. But now this is a very simple way to know your addition facts for the number 9, because that's what it all comes down to. So I've been serving as the human calculator, traveling the world for 30 years. And for a long time, it was just about me, and what I could do, and look what I can do, and then I just leave. You know, I never really shared much. And I invented a new calendar to save us from Y2K in 1999. And it was supposed to come out on 9/9/99. I was really excited. I thought that was the beginning of Y2K. And it was supposed to be in a newspaper story here in Arizona, and it didn't come out. And the guy called me and said, hey, we're going to put it in next week's paper instead. And I said, hey, next week isn't 9/9/99. This is a once-in-a-lifetime date. And he goes, oh, I didn't even notice that. So I was all bummed out. And I was on the golf course with Alice Cooper that day. We were playing golf, and by chance, on the 18th green that day, Alice said to me, hey, 18. I wrote a song called 18. 1 and 8 adds up to 9. How come 18 adds up to 9? And I said, Alice, that's easy. Any number times 9, the answer adds up to 9. If you do 3 times 9, you get 27. 2 and 7 is 9. If you do 6 times 9, you get 54. 5 and 4 is 9. If you do 16 times 9, you get 144. 1, 4, and 4 is 9. He goes, okay, I don't care. And so I was just thinking about this, and I'm driving home from golf, and I'm like, why is that? And I got home, and I looked at my calendar, a 13-month calendar. I'll tell you about that at the end of the show. But for some reason, I just looked at the number 13, and this is on 9/9/99 at 9 o'clock in the morning, just after 9. And for some reason, I looked at 13, and I said, hey, 1 plus 3 is 4. 13 minus 4 is 9. And I just started laughing out loud, like that was just the strangest coincidence to me. And I didn't think much of it for a second, but then I walked by my microwave and I saw the number 11. And I just reflexively went, all right, 1 plus 1 is 2. 11 minus 2 is 9. And I started freaking out. I was like, what is this? How come? My first thought, to be honest with you, was, here I am, the human calculator, traveling the world performing. I thought that I had missed one day in 4th grade when they taught this. It's so simple, you're going to see here in a second. I thought that I just missed that day and nobody ever shared it with me. And so we moved a lot when I was a kid, so I had a lot of reasons to think I just missed it. So I started calling my math friends and say, what is this? What is it called? But here's how it works. Let's start at the simplest number, 10, first number after 9. All you do is add up all the digits in that number and write that total underneath. So 1 plus 0 is 1. Put the total underneath and subtract. 10 minus 1 is 9. Let's try a couple random ones. 15. 1 plus 5, add them together, you get 6. 15 minus 6 is 9. Let's try 19. 1 plus 9 is 10. 19 minus 10 is 9. That works up to 19, but watch what happens over 19. Let's do 20. Here's 20. First step, add the 2 digits together. 2 plus 0 is 2. Put the total underneath and subtract. 20 minus 2 is 18. And look at your answer, 18. 1 plus 8 is 9. Your answer will always add up to 9. The next time you're driving and you see a speed limit sign, you're going to see 55. Add them together. 5 and 5 gives you 10. Put the total underneath and subtract. 55 minus 10 is 45. And look at the answer, 45. 4 plus 5 is 9. So I challenge all of you watching today, write down your age. I'm sure a lot of you have pencil and paper. If you're really good with numbers or just confident, just do it in your head. But think of your age or write down your age, all right? So let me do it too. I think I'm 37 in different number base. So anyway, so it's 37, let's say that. All right, so you write down your age, and now you add those two numbers together. 3 plus 7 is 10. You take that away, and you get 27, and look at the answer. 2 plus 7 is 9. This should have worked for every one of you. This doesn't just work for 2-digit numbers. It works for 3-digit numbers, 4-digit, 10-digit, 100-digit, to infinity. Just to show you, let's just do one more. Let's do 123. 1 plus 2 plus 3. You got to add them all together, and you get 6. 123 minus 6 is 117. Look at that answer, 117. 1 plus 1 plus 7 is 9. This works for every number in the universe. I don't know why we're not teaching this in schools, but there's 2 things I want to share with you. One, I believe this is a simple exercise that will train all of our brains for basic number facts. Instead of memorizing all these numbers, this is a simple exercise that works for every number and will allow you to wire numbers into your brain. But secondly, it's a diagnostic. If you're a parent and you're in the car and your kids are in the back seat and you go by a sign that says 55, if your kids can't say to you, Dad, Mom, 5 and 5 is 10, you got problems, all right? Because they haven't even memorized it, right? But so now that's one step, very simple, right? Next step is they have to add them together and put the total underneath, right? So they got to place that number there. That's not too difficult. Now they have to subtract. 55 minus 10 is 45. And now they have to add up their answers. So between those steps, you will be able to see the gaps in your child's knowledge of numbers and arithmetic. If they can't do 77 because they don't know 7 and 7 is 14, or if they can't subtract it, it just gives you all kinds of insight for teachers and parents to help your kids tune into this language of numbers. And I promise you, if all we did was make sure every 9-year-old kid on the planet Earth could do this, when they're 9 years old, that whole year, every number they see, whether it's a sporting event, a sign, a license plate, whatever, will add up and go back to their age, the number 9. It will make them feel like every number is their friend, and by the time they wake up at 10 years old, they'll be fluent in the language of numbers and basic arithmetic, and now we can teach these kids higher math, algebra and onward. But right now, a lot of kids are struggling because they just have to memorize their math facts, and that doesn't give them a good foundation for number sense or learning any more about arithmetic, and that's why we lose so many kids by the time they get to algebra. And so my mission is to reach every student on the planet Earth before they're 9 years old and share this with them. So I got to show you what happened though. Look at this. I was really bored that day. I had figured out the 0 through 9 thing, and I'm writing stuff down, trying to figure it out. And so I just did this. Check out this picture. I was writing 0 through 9 over and over again, and this thing popped out of my brain. Just focus on the numbers on the right. 0, 1, 2. See the red numbers on the right? They go 0 through 9, 0 through 9, 0 through 9, 0 through 9. Just look at the red numbers. Now look at the red numbers the other way. There's all the zeros, all the ones, all the twos, all the way to the 9s. But now look at the blue numbers, and the blue numbers go the other way. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 through 9, 0 through 9, 0, all the way across. And now look at the blue numbers going the other way. There's all your zeros, your ones, your twos, threes, fours, 5, 6, 7s, 8, 9s. So this is just a number grid that's 0 through 9 twice in 2 directions, and it creates this number grid that goes from 00 to 99. And I was staring at that thing and I saw all these patterns. So I just started scribbling stuff. I've created a coloring book. You can get more information at my website. There's 10 chapters. We won't go through them all today. I'm going to be doing that in a couple weeks. So what I want you to do is just watch what happens when all you do is assign a color for each digit, 0 through 9. This first chapter, chapter 0, in this book, this coloring book, asks you to find all the zeros and color them in that color. So you can see all the zeros end up here. But it's also important to realize all the areas that aren't colored in, they don't have a 0 anywhere here. So this is also a lesson. The next page, they have to find all the ones. And hopefully you'll start to see a pattern here about how numbers reveal themselves in this number grid. You can start to see a plus sign or a cross revealed by each number at its double digit. There's 22. Look at 33, all the 3s, and you can see all the 30s and all the 3s. Here's all the 40s and the 4s, and you can see that plus sign real big now. 50s and 5s, all the way to 90s and 9s. And then the last page of this chapter, you have to color them all in together on this page. So you got to find all the zeros, find all the ones individually, and color it in. This is a great way to prove that you have mastered this chapter. There's 8 more chapters after this, but I'm just going to show you just a tiny bit of the next one because it really blew me away. I found it by luck again, or just by chance. But this chapter teaches all your addition facts. So instead of memorizing all that, look how easy this is on this number grid. This page asks the kids to find all the numbers on this grid whose 2 digits add up to 0. The only one that works is 00, 0 plus 0. That's the end of that page. The next page, you have to find all the numbers on the grid whose 2 digits add up to 1. 1 and 10, 0 plus 1, and 1 plus 0. Now you got to find all the numbers that add up to 2. 2, 11, and 20, because 0 plus 2, 1 plus 1, 2 plus 0. Here's all the numbers that add up to 3. And you can see the pattern. All the combinations for the 4s. Here's your 5s, and this goes all the way, watch what happens. We'll go to 9 just to show you how beautiful it is. 0 and 9, 1 and 8, all the way right through the middle, but it keeps going. Here's all your facts for 10. 1 plus 9, 2 plus 8, 3 plus 7, all the way across. Here's all the numbers for 11, 12, all the way down to 18. So, and then they have to do it all together, and it really captures the cross. So, this coloring book and my 9 pattern are what I'm trying to get out to share with everybody to create a numerate person. And with all of our teachers out there who have been training for years, the biggest challenge they get are kids that just don't understand numbers. And to start there is a really tough place to start. And so if we get all of our students to understand this 0 through 9 and everything goes back to 9, and they get through this coloring book and they're going to learn all the combinations of everything from addition, subtraction, division, multiplication, and differences, this will revolutionize the relationship that children have with numbers, with the amount of confidence they have. And so my foundation is called I Count Foundation. I want kids to learn how to count like me, 0 through 9. But I believe when you help children overcome their fear of numbers and arithmetic, it increases their self-esteem. That's why it's called I Count Foundation. And we're hosting the National Counting Bee. You might have never heard of it. I'm sure you know about the National Spelling Bee, but a counting bee is a little bit different. And here's how it works, is we're gonna do one right now. No pressure, okay? Everybody try this one on your own. First round of the counting bee is everybody has to count by 3 for 15 seconds. And we see how many answers you get, and that's your score. Then you have to count by 4, 5, 6. You go as high as you can, 15 seconds in each round, and you add up your score. But the one thing is that nobody starts at 0. So the first round, if you get up on stage and you have to count by 3, you're going to get a random starting number. So let's say it's your turn. You have to start at 7 and count by 3. Ready, go. So they'd have to say 10, 13, 16, 19, 22, 25, 28. And you'd be surprised. Some kids can go really fast at this. We just had the Arizona Counting Bee to test it all out. And we had students getting over 30 answers in 15 seconds. So you can see how easy this is. So for teachers and students and parents to do this counting bee, we're going to have categories for students in all ages. We're going to have a category for teachers. We're looking for the fastest number crunching teacher in America and around the world. We're going to do an international counting bee. And we also have a division for parents. We want to see what parent out there can pop up. I hope it's a grandma from a farm somewhere that just, is really good at numbers. Who knows who it's going to be? It could be anybody. At one school, we had the counting bee and a janitor won the counting bee, actually beat the teachers and the students. So that was pretty cool. So you never know who's going to do it. And so that's what I wanted to get across to you numerically, was just to show you that numbers aren't scary. Numbers are this amazing language which the whole world is wired in. And if you shut out from that, you're missing a lot of stuff. And so for the sake of STEM and STEAM, science, technology, engineering, and math, and also A should be in there, STEAM, for arts, because I use art to help kids learn math. I really think we could make a big difference here. I really think we could change our future if more kids would enjoy science and math. So obviously, because I'm in this world of numbers, I see things that maybe some people don't. So I just want to share 1 or 2 things with you. I mentioned to you earlier about a calendar that I invented, a 13-month calendar. This is it. It's called the Human Calculator Calendar. You can download it for free at my website, thehumancalculator.com. It's got 13 months. There's the 0 month and then 1 through 12 lined up like a clock. It's a pretty interesting layout, and you can read about that more. But what I wanted to share with you, I just got to take a minute and vent about this calendar that we're using, because it's the Roman calendar. It's been around for 2,000 years. How many days are in a year? 365. On our calendar, we have 12 months, right? So we have 12 months, and some months have 28 days, 29 days, 30 days, 31 days. Nobody knows the pattern. It's really tough to keep track. You can't calculate dates. How far is it from July 4th to Christmas? How many days until my birthday? This calendar we're using really shuts our brain down from getting into the world of time. And so that's why I ended up inventing this 13-month calendar. But before I show you how simple my calendar is, I want to show you how confusing your calendar is. Today's date is March. It's in March, the month of March. Does anybody know what the word March even means? Or February? Some people can't even say it or spell it. January is a two-headed Norse god, back looking into the past and the future. April, May, June, Norse gods. July is named after Julius Caesar. August is named after Augustus Caesar. September is a Latin word which means 7, but September is our 9th month. Oct means 8, but October is our 10th month. Nov means 9, but November is our 11th month, and Dec means 10, but December is our 12th month. I don't know how we've made it this far. We're in 2020. We've got to fix this before Y3K. Kev, can you do something about that? Okay, so anyway, so I'm just saying, your calendar's a mess, and now here's what I have to do to figure it out. I'm a human calendar. So you can tell me a date, and I can figure out what day it was. So Kev, let's use your birthday.
Do I have to?
Okay, pick a date.
June 22nd, 1958.
Okay, so 6/22/58. So now I can calculate what day that was. That was a Sunday. But now there's an algorithm to figuring that out. Here's what I have to do. When I got out of the Air Force in 1988, or no, yeah, it was 88. Wow, a long time ago. I was at the Palm Beach Library and I found this little book. It was like 100 years old. And the guy said there's a pattern in the calendar and you can figure out what day of the week any date is on. And because I was already good at crunching numbers, I was like, all right, I got to try this. And so I sat down and worked this out and wired it in a way that I could do it in my head. So here's the formula. You have to take the year plus the year divided by 4 plus the date plus the month and then divide all that by 7 and the remainder tells you what day of the week it is. That is the only way you can figure out what day of the week it is on this Roman calendar we've been using for 2,000 years. Unless if you call Hallmark, they'll tell you what day it is. But other than that, you got to figure it out. So now here's how it works. So let's do the year is 58. 58 divided by 4 is 14 and a half. So just use 14, you don't, because the next leap year hasn't occurred. The date is the 22nd and the month is June. The month of June has a value of May, June is 4. July is 6, right? So June is 4, and now you got to add all those together and divide it by 7. So if you add up 58 plus 14 is 72, plus 22 is 94, plus 4 is 98, you get a total of 98. And if you divide 98 by 7, the answer is 14, remainder is 0. And that's all I need to know is the remainder is 0. If the remainder is 0, it's a Sunday. If the remainder is 1, it's a Monday, 2 is Tuesday, and so on. And so you can give me any date in history, and I can calculate what day of the week that was on in less than a second usually. So Kev, give me one more, 20th century.
12/2/1995.
That was a Saturday, 12/2/95. You can Google it. And send in your birthday if you want. I'll do some at the end, all right? So this calendar makes no sense mathematically. There's no patterns to it. And so when I discovered this new calendar, I started realizing all these things. There's 365 days in a year. I was visiting a school in Paradise Valley, Arizona for a friend of mine. Her child was in 3rd grade and I was doing the show. And at the end of the show, one of the kids asked me to do my Guinness World Record and to count by the number 28. So I was just messing around. I went 28, 56, 84, 112, 140, 168, 196, 224, 252, 280, 308, 336, 364. And I kept going, but I heard myself say 364 and I was like, wow, that's almost a year. So you're saying 13 times 28 is 364. We could have a calendar that has 28 days in every month. 28 days is 4 times 7. That's a perfect 4-week month. Every month would be the same. That means the 1st would always be a Monday. The 2nd would always be a Tuesday. The 5th would always be a Friday. Our paydays would always fall on the same day of the week. Every month would have the same number of days, 4 weeks. You could calculate how many dates are between days. And so I've been working on this for years. I launched it in 2000 and it still hasn't caught on. So that's my next goal. But anyway, you can download it for free at my website, thehumancalculator.com.
5/30/1970, someone just said.
Oh, that was a Saturday, May 30th. It's good, right? Easy one. Okay. So if you want to learn how to calculate what day of the week a date is on, you can get one of my programs for that. But more importantly, I've invented a better calendar. And so here's how it works. There's 13 months, 28 days every month. That's 364, but I'm missing one day. And it took me that night, I figured it out, was to invent the 0 day. So there are 13 months, but they're numbered 0 through 12. There's a 0 month, a 1 month, all the way to a 12 months. So there's 13 months, 0 through 12. Every month has 28 days, except the 0 month starts on the 0 day. So January 1st is 00, and then we go into 13/28. And every month would be the exact same paychecks, school schedules, everything. It would be so much easier. And from a financial analytical perspective, every quarter would begin and end on the same day of the week. Every quarter would have exactly 91 days. That's not the case now, just so you know, for you fiscals. Just so you know, January, February, and March, 31, 28, and 31 is 90 days. The first quarter has 90 days. April, May, June is 31, April's 30, May's 31, June's 30, so that's 91 days. And then July, August, September is 31, 31, 30. That's got 92 days. And then October, November, December is 31, 30, 31, which has 92 days. So you can see this first half is 181 and the second half is 184. there's 3 days here, and that's where all these people are making all the money. The banks are hanging on to all that money. I'm just kidding, but there's a mistake here. It needs to be fixed. We need to level the playing field and make it where all of us are getting our money. You don't get those weird paychecks during the weekend. You have to wait till Monday. So you can download this calendar for free. It's just a fun, simple way to think about time, and you don't have to calculate all these little fractions to figure out what day of the week it is. As soon as you hear the first, you know it's a Monday, all right? So I'm a bit of a calendar buff. Kev, I'm going to show him one more calendar, all right? Okay, so let me take you to one more calendar right here. This is a one-page calendar. I don't know if you've ever seen one before. I put this out last year. If you're interested in 2020, you can email me and I'll send you a copy of the 2020. We'll have it on the website later this week. But here's how it works. A calendar normally has 12 pages. One page for each month. Here is a one-page calendar. You can fit all 365 or 6 days on one page. So here's how it works. I want everybody to try your birthday first. This is last year. This calendar is for only 2019, all right? So think about your birthday last year. Everybody, you see how the months are arranged up here? They're a little different than you're used to. Find your month of birth up on the top. Find the number of your birthday on the left. And where they intersect will tell you what day of the week it is. So like Christmas, here's December, here's the 25th. That was on a Wednesday last year. So everybody find your birth month and your birthday, and where they intersect will tell you what day of the week it is. And I just put this out for fun. It's more of a novelty than anything, but I can create it for any year. So if you want me to create it for your birth or the year you were born or an anniversary or something like that, just send me an email and I'll throw that together. It's a lot of fun for me. I obviously have some free time. Okay, now, Kev, is there anything you want me to go over specifically? Anything that I didn't touch on yet?
I think you've hit on a lot.
Okay.
But feel free.
Okay, good. All right. So we can go over a couple. Can I just do a couple more things? All right. So there's a simple multiplication trick I want to share with you. A lot of people don't do multiplication two-digit big numbers, but I just want to show you something that happens. This is called complementary multiplication. So if you have to do 96 times 93, that's a lot of work, and I'm sure you all remember how you had to do all that stuff. For me, this is just to show you the beauty and symmetry of numbers, all right? So instead of doing all that stuff you used to do, just off to the right, write how far away each one of those numbers is from 100. So 96 is 4 away from 100, and 93 is 7 away from 100. And now to get the answer, here's all you do, is just subtract diagonally either way. If you do 93 minus 4 or 96 minus 7, you get 89. And that's the first two digits in the answer. To get the last two, just multiply these two numbers out on the left. 4 times 7 is 28, and there's your answer, 8,928. So when I was learning math and we were doing multiplication, there was only one way, with the right to left with the carry. I've discovered 6 ways how to multiply numbers together, and all of them are pretty much more efficient than the way that we were taught when we were kids growing up. And so my mission is to get these ideas out there and just to show kids that numbers and arithmetic can be creative and fun, and it's more about discovering numbers and patterns than just memorizing them, okay? Yeah, so let's do that. Thanks, Kev. Thanks for letting me do that. Next thing is, a lot of kids, we need to make change. Even in today's world, we're still having to make change. And if I said to you, if you have a dollar bill and you're spending 67 cents, what's the change? A lot of you probably can't do it. You don't know how to approach it, or you don't do subtraction well. But there's a simple way to do this. Here's how we're taught. You got a dollar and you want to spend 67 cents, you have to subtract. You got to borrow and all this stuff, and you end up with 33 at the end. But there's a much easier way. Instead of using a dollar, I'm all about the number 9. And so use the number 9 to your advantage. Out of 100 pennies, out of that dollar, take 1 penny and put it in your pocket. Now you got 99 cents, and you can make it happen very easily. Watch this. To figure out change now, you just have to make everything add up to 9. So if you're working on 67 cents, just put the numbers underneath that make all those numbers add up to 9. So a 3 is here to go 6, 9, and then a 2 here, 7 and 9, and then you add the magic penny back and you get your answer, 33, right there, okay? So let's try another one. Let's say you've got to make change for 46 cents. All right, take a second, figure out what the change is, how you would have done it, and now how you can do it here, because all you have to do is put a what here, Kev? 5-3 plus the penny is 54. So let's say you're splurging today. You're going to go to get some fast food, and you're going to buy a meal, and it cost $6.28. So instead of a $10 bill, take a penny away, and now you got $9.99. And your lunch is $6.28. So here's how it works. You just got to make them all add up to 9. You can start on the left because it doesn't matter. 6 and 3, 2 and 7, 8 and 1. And there's your answer plus the penny, $3.72. This is a very simple way to make change, but a lot of people just don't seem to do it. Now, okay, I can already tell what's happening. I can feel it. Everybody that's watched this today is going, what's the big deal about the number 9? Who cares if every number goes back to 9? That's just a cute trick or a pattern. That is not the case. There's a very powerful reason for this pattern. Everybody right now watching, if I asked you 1 plus 1, I know you're going to say it's 2. But the only way you've got that answer is you either memorized it or you counted some objects. That's really the only way. If I ask you 6 plus 6, you say 12. You either memorized it, you added some fingers together, but there's really no other strategy to check your math if you're right or wrong. And so the reason the 9 pattern is a big deal is this. Watch what happens. Look at the number 11. The number 11 is designed to teach us 1 plus 1. That's why there's a 1 and a 1. You've memorized it's 2, you've counted it's 2, you're used to that it's 2, but now you can logically check it. Plug it in, put the 2 here, 11 minus 2, you'll get 9. If you get 9, everything is fine. So watch what happens if you make a mistake. Let's say your kid's having a long day, you're at 11, 1 plus 1, they think it's 3. Let's plug it in. 11 minus 3 is 8, it's not 9. That means that that is the wrong answer. The only answer that will work to make it go to 9 is right there. So watch how powerful this is. Let's do 2 plus 2. So you start at 22. You've memorized it's 4, you've counted it's 4, but now you can check it logically. You think it's 4, let's plug it in. 22 minus 4 is 18. Look at your answer. Does your answer add up to 9? Then everything is fine. This is a simple exercise that will totally give your student or yourself a chance to tune into numbers in a way you never have. And so all I ask is everybody that learns this from me is I just ask you to pick one person in your life that's worse at math than you and share this with them. And I think you'll see when they get it, how much of a difference it will make in their lives. I see it every day when I visit schools. And so please share this with me. If you're interested in the National Counting Bee, the Counting Bee website, thecountingbee.com, you can register for free, put in your scores. We're gonna invite the fastest kids from across America. I want to thank Kevin Hickey and the team at Prevalent for having me today because this is a weird time in our history. And I just wanted to do what I could to help because I feel like if all the teachers and parents out there spent the next couple weeks making sure every kid in America knew how to do this thing where everything goes back to 9, when we all go back to school in a few months, all the teachers are going to be surprised that these kids can do adding and subtracting and all these numbers in their head. Now we're going to take off and really do a lot with STEM and STEAM, okay? And I don't know if you noticed this or not, but I don't believe in coincidences. But if you check out the name of the company that had me today, Prevalent, and Kevin's been a dear friend of mine for 30 years, there's no coincidence, but if you count how many letters are in the name, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're all here today for a purpose. I hope you'll share this message with everybody you know. If you'd like me to come visit your school or do a corporate event or teacher training, just go to my website, thehumancalculator.com. Thank everybody for tuning in today. Stay safe. God bless you all. Thank you.